Very good morning, Rofia. Good morning. I am Val. Good morning, Rofia. Good morning, Oxa. This morning, based on the question posted yesterday, that we solve under organic chemistry. Now, the question number one here is the incomplete oxidation of ethanol yields what? Now, the first thing we need to take note in this question is what is ethanol itself. Ethanol is gotten from the family of the alkanol. And the alkanol, they are having a general molecular formula of CnH2n plus 1OH, or I say ROH. Now, we ask that incomplete oxidation. Remember, what is oxidation itself? Oxidation is the addition of what? Oxygen and removal of what? Hydrogen. Now, when we are adding to this organic compound, ethanol, this is ethanol. Normally, note because it is earth, we are going to have 2 carbon. Now we have C2H5OH. Now, the word incomplete because there is complete oxidation and the incomplete oxidation. Now, when they say the incomplete oxidation, let's put something here that the presence of this O here is denoting oxidation. Another catalyst that can be used in this place is either I make use of K2CL2O7 or KMNO4, potassium permanganate 7 or potassium diisochromate what? 7. Now, look at this place now. When we have this now, this is our ethanol. The ethanol, we have C, we have C. We now have H here, we have H, we have H, we have H, we have H. And then we have what? OH here. They say this thing undergo incomplete what? Oxidation. Now, what is going to happen here is that when we say oxidation, we are removing what? Hydrogen. If I remove hydrogen, I don't need to add what? Oxygen. And if I add oxygen, definitely I don't need to what? To remove what? Hydrogen. Now what is going to happen in this plane? 2 molecules of hydrogen is going to what? To be removed away. And if these molecules of hydrogen is going to what? To be removed away. Now what are we going to have is that we have C, we have H, we have H, we have H, we now have C. Now, this bond in this place, you know we have cleaved away hydrogen and hydrogen in this place. What is going to happen is that we are now having O and what? H in this place. The best thing is that we are going to have C double bond to O, and then we are going to have C single bond to what? To H. Now from this place we have our ethanol. From ethanol we now have what? Ethanol. If you look at the option very well, it is confronting to option what? D. So the oxidation, incomplete oxidation of ethanol is going to give what? Ethanol. So ethanol is our best option. Now question number 2. We have that the monomer of nylon is, they gave us hydroxy what? Benzene. Now what is the structure of our hydroxy benzene? Now, they say hydroxybenzene is otherwise known as the what? The phenol. This is what we call hydroxybenzene. Also, we now say hexane dioic acid. That is, we have 6 carbon, 1, 2, 3, 4, 5, 6. Then I say dioic acid. We have double bond to O, single bond to OH. We have double bond to O, single bond to what? OH. Here we have H, here H. H. Now, in this place here now, when the monomer, what do I mean by monomer is that what? If I have a monomer plus another monomer, I'm going to have a what? A polymer. And our nylon is a what? A polymer. When we have a monomer of hexane dioic what? Acid. The monomer of hexane dioic acid, I have one hexane dioic acid joined together with another hexane dioic acid. I'm going to have a what? A polymer, and that polymer is going to give me the what? The nylon there. So our answer for this question is what? Hexane dioic acid, making option B the best answer. Now, our question 3 is that we have N monosaccharide. What is monosaccharide? Monosaccharide as the simplest form of what? Sugar. Example of our monosaccharide is where we have glucose, we have galactose, and we have fructose. Now, in this place now, our glucose, when I join a glucose, that is a monomer of glucose plus another glucose, I'm going to have maltose. Now, if I join glucose plus galactose, I'm going to have lactose. And if I join glucose plus fructose, I'm going to have what I know as the sucrose. Now, all this one here, the glucose, galactose, and fructose are the monosaccharide. Now, in this place here now, our maltose, lactose, and the sucrose, they are disaccharide. But in this place, they say a monosaccharide is going towards this direction. Now, they now put what? P here. That is, what is going to make a monosaccharide become a what? A polysaccharide. When a monosaccharide joins together, now a mono of saccharide plus another mono of what? Saccharide. They join by the process of polymerization. That is when a what? A monosaccharide and a monosaccharide join. When multiples of monosaccharide join together to give us a what? A polysaccharide, we have polymerization. But when a polysaccharide is now forming with the loss of what? Of water, that is now what we call hydrolysis. That's why we have the polysaccharide plus water. When polysaccharide add together with water, it's going to give me back my monosaccharide. So option C is our best answer. Question 4. The reaction of halogens with alkanes in the presence of sunlight is an example of A. Oxidation reaction. Now, what do we mean by this? We have alkane. Our alkane CnH2n plus what? Plus 2. Now, what do we use to represent our halogen? Halogen is represented with X. Now, then I say, in the reaction, what happens is that if I have an halogen, let's take an methane. For example, we have H, we have H, we have H, and then we have H. We now have plus 1 of the halogen. Let's take example, chlorine. Now, what happens is that the type of reaction that undergo between these two places, let's look at it. I'm going to have that my C, I have H, I have H, I have what? A. One of these hydrogen is going to be replaced with what? With chlorine. We have Cl. Therefore, we now have plus HCl. Now, you can see that one chlorine is replacing this hydrogen, and the hydrogen is now reacting with the word the remaining one of the word the chlorine. Now, what happened there is the what is a substitution word reaction. One molecule is going out and another one is what is coming in. So our best option there is the what? Substitution reaction. Now, question 5. Ethanol is soluble in water due to the presence. We have talked of this in our what? In our first question there. Ethanol belongs to the family of the alkanol. And we said that the alkanol, what did they have? We have what? ROH. Now, because of the presence of this word ROH here, it's going to make them to be what? To be soluble in what? In water, because there's going to be the presence of hydrogen bonding in the ethanol molecule. So the presence of the hydrogen bonding in the ethanol molecule will make our alcohol to be what? Soluble. So the answer there is what? Ethanol. Hydroxyl what? Compound. And what is hydroxyl compound is what? OH. Now, the last question. Alkanols have the general formula of, look at it, we've discussed it in question 1, CnH2n minus 2CHO, CnH2n plus 2CHO. All these options are wrong. This is what is wrong. The best option there is what? D, where we have our alkanol to what? CnH2n plus 1 OA. So this is the what? The general molecular formula for the alkanol, or we can have it to be what? ROH. Any one of what of it that is going to be what? To be given. Thank you very much. We continue with the remaining question later on. Thank you.